Hi, this is my narrated video for Portfolio 2 2A Design. I'm going to use the dataset from the supermodel file to answer the research questions. Does the effective supermodel age, less than 18 years old versus equal to or greater than 18 years old, change with experience? Those who have been working for 4.5 years or more versus those who have been working less than 4.5 years. I will also do the necessary follow-up multiple comparisons to answer the research question, which group or groups of supermodels make the most money, referring to both age and experience. So in order to answer the research questions, I'm going to conduct a two-way independent ANOVA. So the first step that I'm going to do is to recode my predictor variable age into a categorical variable. So I'm going to go to transform, recode into the variable. Going to put age in this box. Name will be age groups. Label will be age group. Click change, click old and new values. For the age group that's under 18, I'm going to type 17.99 in the range lowest through value, and value will be 1. And then for the age group that's 18 and older, I'm going to type 18 in the range value through highest box and type 2 in the value. Click add, click continue. Then I'm going to do the same thing for the number of years of experience. The name will be experience groups. Label will be experience group. Click change, click old and new values. For the experience group that's less than 4.5 years, I'm going to do 4.49 in the range lowest through value. Value will be 1, click add. And then the group that's 4.5 or more years of experience, it'll be 4.5 in the range value through highest box. Value will be 2, click add, click continue, click OK. Then I'm going to go to the variable view. I'm going to change the decimal places for age groups and experience groups to 0. For values, value 1 will be under 18 for age groups, and then value 2 will be 18 and over. Click add, click OK. For experience groups, value 1 will be less than 4.5 years, and value 2 will be 4.5 years or more. Click add and then click OK. And then both of these measures will be ordinal. Now to conduct the two-way independent ANOVA, I'm going to click Analyze, General Linear Model, Univariate. My dependent variable is going to be salary per day, and my fixed factors are going to be age group and experience group. For plots, I'm going to put age groups on the horizontal axis and experience groups on the separate lines. Click add, click bar chart, include error bars, click continue. For post hoc, I'm going to click age groups, Bonferroni, click continue. For EM means, I'm going to click age groups, experience groups, and then age groups by experience groups. Compare main effects, Bonferroni, continue. For options, I want to display descriptive statistics, estimates of effect size, observed power, and homogeneity tests. Click continue, click OK. So here's my output. If we look at the test of between subjects effects, we can see that the main effects of age group, experience groups, and age groups by experience groups are not statistically significant. in order to look at the main effects of specific age groups, we can split the file by going to Data, Split File, Organize Groups, or Organize by Groups. Group space will be on age. We'll sort the file by grouping variables, click OK. Then we'll go to Analyze, Compare Means, One-Way ANOVA. The salary per day variable will be in the dependent list, and then the experience group will be in the factor list. For post hoc, we'll click Bonferroni, click Continue. For options, we'll click Descriptives, Homogeneity of Variance Tests, Means Plot, click Continue, and click OK. So if we look at the descriptives for the age group under 18, we can see that the mean salary was greater among those who had 4.5 years or more of experience than those who had less than 4.5 years. And the tests of homogeneity tests, or homogeneity of variances, were not significant. So this tells me that there was not a significant difference between those who had 4.5 years or more of experience and then those who had less than 4.5 years of experience among the age group under 18. Among the age group 18 and over, we can see that the mean was higher for those who had 4.5 years or more of experience, and then the homogeneity test of variance was also not significant, so there was not a significant difference between those who had 4.5 years or more of experience and those who had less than 4.5 years of experience. So here are my results. To answer the question, does the effective supermodel age change with experience? No, it does not. Whether the age group was less than 18 years old or 18 years old and older, the salary was always highest for those who had 4.5 years or more of experience. And to answer the question, which group or groups of supermodels made the most money, the group of supermodels that had the highest salary were those that were 18 years and older and had 4.5 years or more of experience. I reported these results as there being a non-significant interaction between age group and experience group. And then I also said that the mean salary per day was highest for those who were in the age group 18 and older and then who had 4.5 years or more of experience. And I grabbed these results here from the descriptive statistics in my first analysis, and then the statistics for these ones I also pulled from the descriptive statistics and the ANOVA tables that were in my one-way ANOVA that I conducted second. And then lastly, here is my clustered bar chart that I made to show the mean salary per day by years of experience and supermodel age. Again, the mean salary was highest for those that were 18 years and over and who had 4.5 years or more of experience.